Good morning, fourth graders and parents watching. Welcome to math class. Unfortunately, I don't have any math games prepared for today. April Fools, welcome to April 1st. I hope you're having a great start to the new month. Of course, I have a math game started. Let's get going. All right, I have some of our fraction flashcards here, and these need to be reduced. I want to see if you can say the reduced fraction before I do, okay? All right, here we go. 4/5. We were dividing by what here? 6. 2, what? Did you guess it? 2/3. 2/5. 3/4. Now remember, when you are reducing, you divide to the side. You're dividing the numerator and the denominator out to the side. The number one rule of reducing is try to divide by the numerator first. 6 divided by 6, we can do that. But since we can't divide 8 by 6, you know it's going to be a number smaller than 6. So then we need to think of our factors. Our factors are 1, 2, 3, and 6. It's going to be one of those numbers. And of course, since they're both even, we divide by 2. How about this next one? 1/2. This is where it's important to remember to always divide by the biggest number possible. And our biggest number here is the numerator, 6. 3/5. 1/5. 1/4. 1/3. Last one. 2/3. How'd you do? Did you beat me? I certainly hope so. All right, let's go ahead and get started with our lesson for today. We have been talking about dividing fractions for quite some time now. Now, it doesn't matter whether you have a whole number on this side or a mixed number on the other side, or you switch them around. The rule stays the same. You can only divide a fraction by a fraction. Remember, we've been hearing all this time, you can only multiply a fraction by a fraction, but the same rule applies. We're just switching that multiplication to division. We can only divide a fraction by a fraction. Okay, let's go ahead and take a look at our very first story problem together today. Layla is wanting to make some cookies, and all the sugar that she has is 7 1/2 cups of sugar. And she needs to divide that amount up into equal groups of 1 1/2 because it takes 1 1/2 cups to make one batch of those cookies. So she needs to take all the sugar that she has and put it into equal groups of 1 1/2. If you're putting things into equal groups, that means you are dividing. But we have to remember our rules. You can only divide a fraction by a fraction. We do not have fractions here. We have what? Mixed numbers. So according to our rule, if you don't have one, make one. In this case, we're not going to put a fraction bar and a 1 underneath all of this. We need to do our backwards C. That means we're going to be multiplying the bottom number by the whole number, adding the numerator, the top number, and keep the same denominator. Multiply the bottom, add the top, keep the same denominator. 2 times 7 is 14, plus 1 makes 15. 15/2. Now I'm going to go ahead and keep the division sign just the way it is for right now, and change the 1 1/2. So let's go ahead and do that. 2 times 1 is 2, plus 1 makes 3. 3/2. You want to make sure that you have 2 fractions before you start all of your steps. I'm going to say that one more time. You want to make sure that you have a fraction on each side before you start your keep, change, flip. Meaning we need to have a fraction on the left for our dividend, and we need to have a fraction on the right for our divisor. Once we have 2 fractions, we've got the green light to do our KCF. So let's keep the 15/2 change our sign from division to multiplication. Flip the final fraction. Remember, flip means to invert. We will always be doing the inversion method. That's what it calls it in your book, but I like to think of it as keep, change, flip. 2/3. Remember, our best friend in fractions is cancellation. Let's look diagonally. If we have a match, we're dividing by that number. 2 divided by 2 is 1. The smaller number here is 3. Can we divide 15 by 3? Well, of course we can. That gives us 5. 3 divided by itself is 1. Multiplying fractions is no problem. Top times top. Bottom times bottom. Let's examine that fraction. Is it proper? No. Let's throw that 5 in the division house. Divide by 1. 5 divided by 1 equals 5. Now, you know and I know, since this is a story problem, we have to have a label at the end. We cannot just have 5 as our answer. Let's go back and look at that question again. It's asking how many batches of cookies is she going to be able to make? And Lila could make 5 batches. B-A-T-C-H-E-S. I hope they're chocolate chip. Okay, let's go ahead and look at section 2. Section 2, letter E. Remember our rule, we can only divide a fraction by a fraction. If we don't have one, make one. 30/1. Okay, so we have a fraction over here, but do we have a fraction for our divisor? No, we do not. Let's do our backward C. That means keep. Let's see. Backward C, we're going to multiply the bottom and the top. 7 times 2 is 14 plus 1 is 15. I'm going to rewrite this. 30/1 divided by 15 halves. It's very important to make sure that you have a fraction on each side first before you do your 3 steps, your keep, change, flip. Now that I have a fraction on the left and a fraction on the right, let's do our 3 steps. Keep, change your sign from division to multiplication, flip the final fraction. Look diagonally. The smaller number here is 15. We always want to see if we can divide by that smaller number, and we can. 30 divided by 15 equals 2. 15 divided by itself equals 1. Multiply across. 4/1. Is it proper? No, it's not. It's improper, so let's put that 4 in the division house. 4 divided by 1 is 4. Okay, for the rest of your front page today, you're going to be practicing dividing fractions, but be careful. You might have some whole numbers thrown in there. Remember to put that whole number over 1 first. You might have some mixed numbers, so do your multiply the bottom, add the top, keep the same denominator. What I would like to do at this time is I would like for you to turn the page and look at the back. We're going to take just a moment and review one of the very important things that we have learned this year that we want to make sure that we continue to work on through the duration of this year, and that is complex division, complex long division. Now, the reason why we call it complex is because if we look at the divisor, you'll notice that there are 2 digits there, 91, a 1 and a 9. Because there are more than 1 digit there, we're going to add an extra step, and you'll see that extra step in purple. That step is the E. E means we need to estimate. You and I, we do not know our 91 multiples. You might could do it 91, okay, 182, but after that, you probably couldn't count by 91. But could you count by 9s? Sure. Could you count by 10s? Of course we can. Estimate means we're only going to be counting by 1 number. So let's take a look at that. The very first step during complex long division is to estimate. That means we need to underline the digit that is in the greatest place value. That is our 9. Circle the right neighbor. Remember, the right neighbor is always the neighbor to the right. Okay. Now look at the neighbor that you circled. What is it? It's a 1. Let's remember our rounding rule. 4 or less, don't mess. 5 or more, up the score, and add 1 more to the underlined digit. I'll say that again. 4 or less, don't mess. 5 or more, up the score, and add 1 more to the underlined digit. So look at the number that we circled, our neighbor, our right neighbor. Was it 5 or more or 4 or less? 1 is less than 4. Since it is less than 4, we are not going to mess at all with the 9, meaning we're going to keep the 9 exactly the way it is. So when we start to count, we will count by 9s instead of counting by 10s. Now, look at your dividend, 97,643. You'll notice that there are 1, 2, 3, 4, 5 digits. That means we need to have 5 somethings up top. So let's go ahead and put our X's where they need to go. Can 91 fit into 9? Of course it can't. So let's put an X on top. And that takes care of our very first place. Now, can 91 go into 97? Yes, it can. When you get to the yes part, that's when you need to go back and look at your estimated number. Your estimated number was a 9. Now let's use just that number. 9 can go into 9 how many times? 1. Put 1 above the 97. Now we are done with the estimating part. We just divided. Now let's look at our next step. Our steps are out on the side in purple. So after we've estimated, after we divided, multiply by the original number. 1 times 91 equals 91. Remember, anything times 1 equals the other number. Go straight down, put your 1 and your 9. We just multiplied. Now it's time for us to go to our next step of division, which is to subtract. Take 1 from 7, 6. If the numbers are the same, 0 is the game. C means to compare. Is 6 smaller than 91? Yes, it is. Now it's time for our next step, which is to bring down the 6. After we brought down the 6, it's time for us to go all the way back up and start our 6 steps of complex division again. Go back up to your estimated number. Your estimated number was the number that we underlined. What digit did we underline? The 9. Go back to your 9. 9 can go into 6. How many times? Now remember, just like I'm not using the entire 91, I'm not using the entire 66 either. 9 goes into 6. How many times? 0. Put a 0 on top. We have just divided. Now it's time for us to multiply. 0 times 91. Remember, we always go back to the original number. 0 times 91 equals 0. Remember, anything times 0 equals 0. That was the multiplication. Now it's time for us to subtract. $66 minus nothing equals 66. The C stands for compare. Let's compare this. Is 66 smaller than 91? Yes, it is. Remember, it must always be smaller than your divisor. Since it is smaller, let's bring down our next digit that's in our dividend. We're bringing down the 4. Now that we've brought down, go all the way back up and start your steps again. Our first step is E, estimate. Look at your estimated number. Our estimated number is 9. 9 goes into 6. Well, it can't do it. So let's scooch over one more digit. 9 goes into 66. How many times? Well, let's see. If we were to count by 9s, the closest number that we get to is 63. 9 times what gives us 63? 7. That was the division part. Now it's time for us to multiply. Multiply 7 by the entire 91. 7 times 1 is 7. Go straight down and put your 7. 7 times 9 is 63. We have just subtracted. Oops, nope, we just multiplied. Now it's time for us to subtract. Okay, can we subtract 7 from 4? No. Bigger bottom, better borrow. 6 becomes a 5. 4 becomes a 14. Take 7 from 14, that gives us 7. Take 3 from 5, that gives us 2. We have just now subtracted. Let's compare. Is 27 smaller than 91? Of course it is. Bring down the next digit, which is a 3. Let's go back up and start our steps one final time. Go up to the estimated number, which is 9. 9 goes into 2, can't do it. 9 goes into 27, how many times? 3. Put a 3 on top. We have just divided. Now it's time for us to multiply. Multiply 3 by the entire original divisor, 91. 3 times 1 is 3. Go straight down, put a 3. 3 times 9 is 27. It's time for us to subtract. If the numbers are the same, 0 is the gain. Great job, students. Okay, so all we would need to do at this time is add in our comma. 1, 2, 3, comma. 1,073 is our quotient. Remember, it's called a quotient because the queen sits on top of her throne. All right, now, the directions also say that we should check this problem. How we check this problem is we go out to the side, we multiply our quotient by our divisor 91, and that should give us our dividend, 97,643. Okay, students, your tasks for today are as follows. Number 1, let's go back to that front page and do as much as we can with our dividing fractions. Number 2, go on to the back page, which is all review, and I can't wait to see how well you did on your review page for today. I look forward to seeing you at our FaceTimes today or tomorrow. Until then, I'll see you next time. Bye-bye.